Hey everybody, it's Coach Stoltenberg. Um, Doing a quick video today to help you with your pH and pOH calculations. You had this worksheet assigned to you already, so hopefully most of you have already worked through it and gotten some feedback. Today's video is I'm going to work through it. So if you're unsure of the mistakes you made or what you're doing wrong, hopefully you'll be able to figure it out. So um, just go through each of these problems and make sure we're all on the same page. Alright, so I'm going to switch over to my whiteboard here and we'll go starting with number 1. This is determine the pH of a 0.0043 molar HNO3 solution. So we have 0.0043 molar HNO3, that's nitric acid, and we want to know what the pH is. So we're solving for pH in number 1. So remember, there's a couple different ways that we can solve for pH, right? We know that pH is equal to the negative log of the hydrogen ion concentration, or the hydronium ion concentration, which can be written as H3O plus as well. Or if we're given a strong acid, strong acids are equivalent to the H plus concentration because they completely dissociate. So what we're really doing in this one is using the negative log of the concentration of a strong acid, because we're not given the H plus concentration, we're given the molarity of an acid. But remember, these three things are all essentially the same. So here, 0.0043 molar, this is the concentration of a strong acid. This is an acid. Alright, so we're just doing this. So I'm going to erase this. I'm going to actually write it in what I'm doing. Now I'm writing it in, but I'm not actually doing this because I can't do freaking logs in my head. You can't do logs in your head. I don't know of anybody in the world that can do logs in their head. So really the work is being done by your calculator, but I still want you to write out what you're doing so you understand it. I'm using pH as equal to the negative log of the acid. So what I'm punching into my calculator is the negative log of 0.0043. Once I've written that down, now it's just a matter of punching it into my calculator. So here we go to our calculator here. Again, find the negative button first, negative, the log, then just punch in the concentration of that acid, 0.0043, enter. 2.36665 blah 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 blah. We have 2 sig figs here, so I'm going to round my answer to 2 sig figs. If you rounded this 2.37, that would be, I wouldn't take off for that, but I'm going to say my final answer is 2.4. pH is 2.4. There you go. It's that simple. All you have to do is just remember that the same, given the concentration of an acid is the same thing as giving you the concentration of H plus. So all you have to do is take the negative log of it. Alright, 2.4 is our pH of our for the answer number 1. That makes sense because it's an acid, and the pH of 2.4 would indicate that it's acidic. Alright, look at question number 2. Question number 2 looks familiar, right? It's very similar. It says determine the pOH of a 0.0043 HNO3 solution. So again, we're using 0.0043 molar HNO3. And we're looking for, this time, pOH. Well, if we hadn't have done the first problem, this would be a little bit more complicated, but we already did the first problem. The first problem we figured out the pH of this solution is what? We figured out that this pH is equal to 2.4. So we already know what the pH of this solution is. So finding the pOH of this solution should be pretty easy, because we're going to use this equation. pH, remember at all times, if you know the pH, finding the pOH or vice versa should be pretty easy, because this is always true. pH plus pOH is equal to 14. In this case, since we're solving for pOH and we already know pH, it's really, really simple. We just rearrange this to where it says pOH is equal to 14 minus pH. So pOH 14 minus 2.4, which is equal to, who are all my math wizards out there? 11.6. pOH is 11.6. There you go. Simple, simple, simple. If you know the pH and you're looking for the pOH, it's very simple. Subtract from 14. Alright, cool. Moving on. Let's look at number 3. Number 3. Determine the pH of a 6.4 times 10 to the negative third molar NaOH solutions. Alright, so I have 6.4 times 10 to the negative third molar NaOH, and I'm looking for the pH. Okay, looking for the pH. Alright, so a lot of kept seeing the same mistake over and over again, and it's every year I see the same mistake. People just automatically say, oh, pH, well, we got pH, so we're taking the negative log of something, right? We're solving for pH. Negative log, in this case, you know, it's either H plus or an acid or hydroxide, or I'm sorry, H plus or hydronium, or the concentration of an acid. But you have to pay attention to what you're being given. This right here, not an acid. This is a base. So if I take the negative log of this number right here, I'm not solving for pH. Negative log of this number right here isn't giving me pH, it's giving me pOH. But like I said in the previous problem, if you know pOH, it's really simple to find pH. So this is a two-step problem. Because you're given a base to start with, you actually have to solve for pOH first, then you solve for pH. So the first thing you're doing, you are doing the negative log of this number, but you have to realize that when you're doing that, you're solving for pOH first, because this is a base. This is what you're doing first. The negative log of a base. So pOH is equal to the negative log of 6.4 times 10 to the negative third. So that's what we're punching into our calculator first. So let's do that. Alright, negative log. And then we have 6.4. And then you could do this a couple different ways. You could literally type in times 10 to whatever. Or you could use this function right here, times 10 to the negative third, and that should do it. 2.19. 2.19. So our pOH is 2.19. So how do we find pH? We take that number and we subtract it from 14. 14 minus 2.19. Where are my math wizards at? 11.81. This is your final answer. This is what I'm talking about when we're doing these problems. You have to pay attention to what you're being given. If you could be using the right, technically the right math, punching the right buttons in your calculator, but you could be solving for the opposite thing of what you're intending to solve for. In this case, taking the negative log of this number gives us pOH, not pH. But once we know pOH, it's very simply subtracted from 14 gives us the pH. Alright, moving on. Let's look at number 4. Calculate the hydronium concentration of a solution with a pH of 5.8. Okay, so we have a pH, it's 5.8, and we want to know the H3O plus concentration. That's what we're looking for, right? Alright. Okay, so what are our equations for this? Well, we really only have one. There's actually technically two, but I'm only teaching you one. So the concentration of H3O plus is solved for by doing what I call the anti-log. I don't even know if that's correct to call it that, but that's what I call it. 10 to the negative pH. This is pretty straightforward. We're given pH, 10 to the negative pH. That's all we have to do here. So 10 to the negative 5.8. Alright, so going back to our calculator here, we hit second, and the log button gives us the 10 to the whatever. Then we just type in negative 5.8. Oh, forgot the decimal. Enter. And the calculator tells us this number. Hopefully by now we all understand what this is telling us. 5.8. That E is just the calculator's way of expressing scientific notation. So what this really is saying is 5.8 times 10 to the negative 6. So our H plus concentration, our hydronium ion concentration, is 1.58 times 10 to the negative 6. Very simple. Calculator's doing all the work. If you don't have a second function on your log, you could just do it another way. You could just say 10, type in 10, and then do your little up arrow, and then just hit negative 5.8, and look at that, you get the same answer. Crazy, right? Alright, let's look at number 5. Number 5, the pH of a solution is 2.3. What would be the hydroxide concentration? Alright, so this is a little bit different. We have a pH that's 2.3. This time we're looking for the concentration of hydroxide though. Okay, so what's the only equation we can use to solve for hydroxide? It's this one right here. Hydroxide concentration is equal to 10 to the negative pOH. Well, I don't have pOH, right? I have pH. So again, this is a two-step problem. You have to use pH to find pOH first. Then you can use this equation. So the first thing you're going to do, pOH is what we're solving for. But that is really simple, right? 14 minus the pH. 14 minus 2.3. That gives us a pOH of 11.7. Now that we have our pOH, very simple. Just plug it into there. Hydroxide concentration is equal to 10 to the negative 11.7. And then it's just a matter of the calculator doing the work. Clear. Second log, negative 11.7. Enter. 1.995 times 10 to the negative 12th. I'm just going to round that to 2. And we're going to finish with a hydroxide concentration is 2.00 times 10 to the negative 12th. There you go. Super, super simple. Again, just paying attention to what you're actually being given and what you're solving for. All right, number 6. It's kind of taking all this and putting it into one problem. So the solution has an H plus concentration. So it's giving us H plus. So I'm going to write that down. It is 1.65 times 10 to the negative 8. And then it's asking us for pH, pOH, and the hydroxide concentration. So this is taking all of this information and basically making you use it all in one problem. So you have to ask yourself, which one does it make sense to solve for first? Well, I kind of gave you a hint by listing them in a specific order. I listed pH first because pH is what you have to solve for first. This is the H plus concentration. Based on the equations that we know, this is the only one that we can use, or the only thing we can use this to solve for is pH. Once we know pH, we use pH to solve for pOH. Once we know pOH, then we can use that to solve for hydroxide. Very simple here. So let's start with pH. We know pH is the negative log of H plus, right? So it's the negative log of 1.65 times 10 to the negative 8. So again, it's just a matter of punching it in your calculator and making it do the work. Negative log, punching in the number, 1.65 times 10 to the negative 8. Don't even have to close the parentheses. Just hit enter. 7.78. So pH 7.78. All right, there's first step. All right, now that I know the pH, finding the pOH should be pretty easy, right? What do we have to do? That's right, just subtract it from 14. 14 minus 7.78. Oh, what is that, 6.22? Let's just make sure. It's early and my math maybe not be so great right now. 7.78. Yes, it is 6.22. That's your pOH. Now, once you know your pOH, solving for hydroxide is very simple. Hydroxide concentration is equal to 10 to the negative pOH. So it's equal to 10 to the negative 6.22. So again, just make the calculator do the work for you. Second log 10 to the negative 6.22. Boom. Final answer, 6.03 times 10 to the negative 7th. There's your 3 answers. Okay, we started with hydrogen concentration, or hydrogen ion concentration. We use that to solve for pH. Once we know the pH, we use that to solve for pOH. Once we know pOH, we use that to solve for hydroxide. Very simple, simple stuff. If you have one of these 4 numbers, you could solve for the other 3 pretty easily. You just need to know the order in which to do it. In this case, we had to solve for pH first, then pOH, then hydroxide. Very, very simple. Calculator's doing most of the work. All you really need to be able to do is know what buttons you're pushing and know what you're actually solving for. All right, that's going to be do it for this one. I hope this clears it up for some of y'all, and y'all have a good one. See ya.